Okay, what we're going to look at now is some B grade trigonometry. Now remember, there's a few things in maths that require work with right angle triangles. These are right angle triangles, of course, because there's a right angle there. The two things, the main things that use right angle triangles are Pythagoras and trigonometry. And the difference is, with Pythagoras, they will give you usually two sides and you will be required to find the third side, whereas in trigonometry you will have either two sides and you have to find an angle, or a side and an angle and you've got to find the other side. So this is trigonometry. You can see we've got two sides given, and the question says work out the size of angle BAC. Now BAC, the way you find that is to go from B to A to C, B to A to C, and you can see it goes around that. BAC, so it's there. I'm going to put a little X there so we know that's the one we're going to find. So of course this is trigonometry. First things first, when you do trigonometry, make sure your calculator is in degrees mode. This is just the way you measure angles, degrees. Other ways are gradians and radians, and you don't have to use those. Well, radians you won't use until A-level maths, but in GCSE you'll only use degrees. So make sure your calculator has a little D there as opposed to an R or a G. If it doesn't, then you're going to have to change it, and I think on a Casio you press Shift Setup, and then you can see you've got the options 3 deg, 4 rad, 5 grad. Make sure you press 3. If you've got a different kind of calculator, there might be a button that says DRG, or you might have to go into your settings. But always make sure you're in the degrees mode. So now we can start. Now, you may have been told already that there are 3 triangles, formula triangles, you need to remember. And whenever I do trigonometry, I always make sure that they are written somewhere on the page. So let's write them down. You've got sine theta. Theta, remember, just means the angle. You've got the opposite, and you've got the hypotenuse. Okay, and that makes a formula triangle like this. So for example, if you wanted to find sine theta, you'd cover it up, and you can do opposite divided by hypotenuse. That would give sine of the angle, not the actual angle, but sine of the angle. We'll look at that later. If you wanted to find the opposite side, you cover that up. So that means you've got to do sine theta, sine of the angle, multiplied by the hypotenuse. And if you wanted to find the hypotenuse, if you cover that up, you'd do opposite side divided by sine of the angle. Okay? So the others, you've got cos of the angle, the adjacent, and the hypotenuse. And the last one, you've got tan of the angle, the opposite, and the adjacent. And the same rules apply for finding each one. So let's have a look at this question. We've got, first of all, we need to find out which one we're going to use to help us find the answer. So look at the question. Of the 3 sides, the opposite, the adjacent, and the hypotenuse, we can see that we've got the opposite in the question. We've got the adjacent in the question. The hypotenuse is totally blank, there's nothing there, we don't have to find it, and it's not given us in the question. So we're looking for the formula triangle that has adjacent and opposite, but not the hypotenuse. So you can see that one's got a hypotenuse, it hasn't got the adjacent. This one's got the hypotenuse and it hasn't got the opposite. This one's got the opposite and the adjacent and no hypotenuse. So that's the one we're using, the tan one. Okay, so now we want to find this angle. Now to find the angle, this is what we've got to find first, the tan of the angle. Okay, so if you cover that up, you can see you've got to do the opposite divided by the adjacent. So that would be 2.3 divided by 7.4, which I'm going to do like that. Now I could do that on my calculator. I could do 2.3 divided by 7.4. And it gives me that. 23 over 74. On a Casio you press the SD button, you can get it as a decimal. But that isn't the angle, remember. Now to get from the angle to, so the tan of the angle, which that is, to get from that to the actual angle, we need to go back. And if you look, there's a tan button. Above it is tan to the minus 1, inverse tan. That will take us from the tangent of an angle, tangent just means tan, that it'll take us back to the actual angle. It works in a similar way to the square root key. The square root key would take us from the square number, for example 81. If you press the square root of 81, it'll take us back to the number you squared to get 81, which would be 9. So if I press shift tan, you get the tan to the minus 1. Now I can put this, use this answer button. That will bring up the last answer, which I'd worked out as 2.3 divided by 7.4, and I've got my answer. And if I press equals now, I'll get the answer. I'll get the actual angle. But I'm not going to do that. What I'm going to do is I'm going to do all in one. So tan to the minus 1 of 2.3 divided by 7.4. So 2.3 divided by 7.4, all in brackets. So I'm going to write this here. So tan to the minus 1, inverse tan, of 2.3 divided by 7.4 will give us the angle, which is 17.2658095. Now the question says 3 significant figures. So to get 3 significant figures, we can start counting, remember, from the first number that is not 0. So that is actually the first number. So 1, 2, 3. So we don't want that. But because that fourth significant figure, 6, is above 5, or 5 or above, 5, 6, 7, 8 or 9, it pushes the 2 up by 1, so you get 17.3. We still haven't got all the marks though. It's a 3-mark question, I think. We need units, it's an angle, so degrees. Let's go on to the next question. So now, work out the length of AC. So there's AC there, so we're trying to find a hypotenuse. I'll call that X again. So, we've got a hypotenuse involved in the question. I know they haven't actually given us told us what it is, but it's involved in the question because we've got to find it. This one here, 4.7, has been given, and that's an opposite. So we've got hypotenuse and opposite, no adjacent. It's not involved, we don't have to find it, it's not given. So, which formula triangle has the hypotenuse and opposite in? That is the sin triangle. So SOH, I'm going to write it in over here as well. So, to find the hypotenuse, I'm going to cover up H, and you can see it reveals an O above the S. So that means we're doing the opposite, which is 4.7, divided by the sin or sine of the angle 32. So sin 32. As soon as you work that out, you'll get it. So 4.7 divided by sin 32. So sine of the angle equals 8.8692 and so on. 8.8756. Again, 3 significant figures. So 1, 2, 3. Don't need that. 9's big, so it'll push the 6 up to 7. So 8.87 units. It's a length given in centimetres over here, so centimetres. Question 3. PQR is a right angled triangle. There we go. Work out the length PR. So it's another hypotenuse. Give your answer to 3 significant figures. So again, we want the hypotenuse, we've got an adjacent because it's next to the angle, and the opposite is just not involved at all in the question. So, which triangle uses the hypotenuse and the adjacent? You can see that it is the cos triangle, the cosine it's called. So, write it in again, C-A-H. Right, so, I want to find the hypotenuse. Cover up H, that means we're doing the adjacent, 4.5, divided by cosine of the angle. So cos 53. So let's work it out. 4.5 divided by cos 53. 7.477. And so on. 3 significant figures. So 1, 2, 3. That's big because it's 5 or above. So that 7 goes up by 1 to 8. So it's 7.48. And the units, centimetres, so centimetres. There we go.